The sun, the bright sun that brings back not light alone but a new life and hope and freshness to man, burst upon the crowded city in clear and radiant glory.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts here in England and Norway, Matthew Russell and Chris Carney.
Oh, yeah, baby
Dickens.
I've decided to go with a bit of proper literature, Dickens, because you're such a thespian these days, Chris. I heard your Sainsbury's advert and I thought that was absolutely marvellous.
Well, thank you very much.
And I thought I'd try and gain your thespian skills at the start of the podcast.
Well, I'm always here. You can talk to my agent.
That little bit of quality. It's going very, very well, isn't it? Your little advert.
It is. It's done a bit of
moving.
Distance as well. And there's obviously, as we were just discussing before we started recording, there's the first of the three adverts, which had a bit of a racist backlash, has caused a bit of unity between all the supermarkets of the UK as the hashtag Stand Against Racism, which Channel 4 got behind. So actually really, really good. So I'm very proud to be a part of something quite positive, even though it is from a massive corporation. It's quite nice.
But, you know, I've got something slightly more frivolous, of course. But I've got to thank the Spodcats, because I know that some of the Spodcats tuned into my other podcast, Recovering Queen.
Wonderful.
And that went to number 1 in the iTunes music chart.
Can we get a rewind on that? That is number 1 in the iTunes music chart.
I've never had a number 1 podcast before, Chris.
Have you had any number 1s though, Matt?
I've had a couple of number 1s today.
It's important to stay regular. That's so honestly, I'm really proud of you, man, because I know you. This is your passion. Queen is your other passion. It's like, you know, it's incredible. Like, and I love the podcast. It's sounding fantastic. I mean, I'm a non-Queen fan. I'm learning everything. Every single second I'm learning something on it. but it's great. And you guys have a great rapport. Like, I mean, that's the main thing. You got these guys who all just have the passion, and it all comes through. So well done, my friend.
Well, thanks very much. Well, we've managed to do about 3 minutes without even mentioning space yet.
Yeah,
so I think we better correct that
Yes.
and go, right, it's time for Space Legend of the Week.
Week.
It's someone's birthday today, an astronomer called Marta Borghi
Yes.
from Italy. Marta Borghi.
Where the best astronomers come from, isn't it?
Galileo, obviously, being quite a good one.
He's OG.
Overrated.
No, OG. Sorry, not
What's
overrated.
OG?
He's certainly not overrated.
What's OG?
Original gangster.
He is a bit of an original gangster for sure.
Absolutely.
An Italian radio astronomer, Marta Borghi, her claim to fame was she discovered the first double pulsar, so 2 pulsars orbiting each other.
Goodness me.
From the 64-metre Parkes radio telescope in Australia. And that was her 2005 PhD paper that won the Pietro Taccini Prize by the Italian Astronomical Society. And of course, she's got the obligatory asteroid named after her, like virtually everyone does. And I'm actually getting a little bit worried that I don't.
I've got a couple.
Have you already?
Yeah.
Not
yeah.
surprised.
Since I started doing this.
Oh, God damn it. I'm so jealous. Well, anyway, happy birthday to Marta Borghi, absolute space legend astronomer. While we're speaking, Chris, I think the Chinese are getting ready to land on the moon.
Is that old Changi 5 again?
That's the old Changi 5 or the Chang'e 5.
Oh, sorry.
I don't know how to pronounce it. So I think Changi 5, that's fine, but Chang'e, I don't know. I was actually looking up at, this week, there was some, about 2 days in a row, there was a beautiful Mars and Moon conjunction. Conjunction being when they're quite close to each other and make a pretty picture. And it was beautiful, actually. I think on Wednesday night it looked absolutely stunning. But while I was looking at it, I was thinking, crikey, China's actually got spacecraft going to both of them right there and then. One was going to the moon and another one's off to Mars. So I think that says everything about the Chinese space ambitions.
While we're all talking about it, they're doing it.
They are doing it. And so 5 days after it launched, which it did launch after we said it was going to launch, and it did indeed launch, and it was a beautiful launch, and everything seems to be going okay. It's managed to get itself into orbit around the moon on Saturday, I believe that was.
Excellent work.
And it's getting itself into the position to do the descent to the surface. So, yeah, I think it has to do something like 3 8-hour orbits to get it into this circular orbit before it attempts the landing. But yes, that could actually happen. In about 2 hours, that actually might happen.
Oh, wow.
Like 8:30 this evening. So all the listeners tomorrow will, of course, know this when this is actually released. But it's really exciting. But I was a little bit disappointed that I saw that NASA tweeted a couple of times saying, congratulations to China for doing this. But they always finished it with a sort of snide remark of, we hope the Chinese share it like we did. Kind of which, if anyone who's a parent knows, that's a terrible bit of human psychology right there.
Yeah.
It's like goading them not to.
I love it. It's almost like they're putting China on the naughty step.
Yeah, well done. Well, yeah, but make sure that it's a bit weird. I didn't like it. I thought it's much better just to rise above it, be the better person.
Yeah, because that's what space exploration is about. It's literally about that.
Yeah, exactly. Wait until they don't share it before you have a go at them.
Yeah.
This will be the first time in 44 years that something has gone to the moon to retrieve moon samples. Yeah. So there's been 9 missions that have retrieved moon samples. That's 6 Apollo missions and 3 Soviet lunar missions. And Luna 24 was the last one in 1976. The year, in fact, that happened a couple of months before Marta Burgay was born. So there you go. So Marta Burgay, who's had a career in astronomy, that's all happened since the last time we went to go and get moon rock.
Amazing. I mean, we're not counting
a whole life.
But we haven't counted all the numerous times that Mr. Spoon went up there, though.
I believe that doesn't count because because Mr. Spoon isn't human. He's an alien of unknown origin.
Yeah, that's true. That's true.
Time to drink, Chris. Time to drink.
Sounds like it's
Elon Musk.
Oh, drink! I've just realised there's a bit of a problem with the Elon Musk drink game on the change of it's a change of date that we put the podcast out on now, because when it was out on Friday, people drinking to Elon Musk,
yeah,
it now comes out on Monday morning. So anybody who's playing the Elon Musk drink game, it's definitely got some
good
problems.
On them. That's what I say.
Yeah, actually, that's what I should say.
It's the only way to make your work day bearable, surely.
Yeah, absolutely.
Who doesn't go into work half cut, Chris? Come on.
I don't even go to work anymore.
Yeah, who goes to work? I should have just finished there, shouldn't I? Yes, Elon Musk has become the second richest person after Jeff Bezos.
Amazing.
So the 2 richest people on Earth are rocket men.
Yeah.
And I ask you, Chris, do you think that that's a coincidence?
I believe that it is the way things should be.
I think it's because they're so rich because they must have some kind of vision. They're visionaries, I suppose. But they see the future in space, don't they? So yeah. It's either a very good thing for space or I just can't work it out. But it's got to be more than a coincidence, hasn't it?
Have we overtaken Bill Gates?
Yeah, he's overtaken Bill Gates. Elon Musk has overtaken Bill Gates because the Tesla share price went up.
This is very interesting because obviously what I was going to say then is that Musk and Bezos have that ambition, and that ambition obviously, goes beyond Earth, which sounds a bit trite, but stick with me on this. But Bill Gates seems to have dedicated more of his time to humankind on Earth, and maybe that's not something that people are as excited by. But I think maybe I feel it's just as worthy. I mean, perhaps that's where the sort of, because this is all about status as well. It's all about, how people view the person and what their interests are. And I think maybe people are just more excited about the space side of things than they are about the helping humans to have things like clean water.
It's got to be two ways of thinking, isn't it? Bill Gates is, what an amazing person. What he's doing is incredible, I have to say. And I've got a lot of time for Bill Gates and that whole spending all the money that you possibly can on trying to solve the big problems. And that's brilliant. But I actually think that you need both. You need your Musks and your Bezoses, and you need your Gates and Buffets, don't you, on the other side? I.e., I don't think that there is it's not a polar thing, is it? It's a
no. I fully agree.
Dichotomy. I think I think there's room for both.
Yes,
but
without a doubt.
Here's the incredible thing. Elon Musk's got a great week this week because more Starlinks have gone up. So that's 955 up there now.
Wow.
And 955 have been launched. There's 895 in orbit, which is just insane.
Yeah.
But the booster that carried them there was the 100th Falcon 9 launch.
Wow.
Yeah, I know. It almost feels like the Falcon 9 just isn't that older vehicle. And I can't think of many space systems like that, launch systems, that have done 100 launches. I mean, it's just insane.
Yeah.
But the incredible thing about it is that the booster that flew is over 2 years old, and that's its 7th time of flying.
And landed. 7
times it's flown up. The first one being 2018, which was a Telstar. Then it did the final Iridium mission, then's done 4 more Starlink missions, and then finally this one. So, yes, 7 missions since September 2018.
So what's the shelf life on it? Is it still good to go?
Yeah, I think they're supposed to do something like 20 or 30. Well, just keep going.
Yeah.
I actually can't remember, but I'll pop it in the notes.
Yeah.
The other one this week, which I'm going to have to say, if this happens, I'm going to have to change my best space event of the year from the Chang'e 5 mission to this. So Starship SN8.
What a beauty.
Which does look it looks absolutely amazing. The footage coming out of Boca Chica by all those people that are down there is just amazing. I love the one where they were mating the sort of 2 large sections of it and the people are standing around and you get an idea of just how the scale of it and how big and shiny it all is. And it's just, wow. But yeah, so SN8, after a few issues with the engines, the Raptor engines, had a really good static fire test. And Elon Musk instantly tweeted that he was going to go for a 15-kilometer hop. So that's going up 15 kilometers, which is that's a lot. That's pretty high. And then they're going to be testing the 3-engine ascent, the body flaps, which are powered by Tesla's motors and batteries, which is quite fun.
Yeah.
The transition of using the header tanks. So the header tanks are these extra tanks that have fuel that's not sloshing around at that point, so that you've got a more controlled burn for the engine. So they're going to be testing that transition. But the big bit is the landing flip, where the Starship essentially is belly flopping in, and then at the last moment sort of corrects itself, but as it corrects itself, it overcorrects itself, and so has to undercorrect itself back again and land on the launch pad. And that maneuver just looks absolutely insane in the videos. So if that genuinely happens this week, I think that's going to be just incredibly mind-blowing. It's just going to be, what the hell just happened there? Musk thinks that's a 30% chance, but he is known for hedging his bets like he did with Falcon Heavy. So, might it be the space event of the year if that happens?
Well, at Chang'e 5 are just going to be like, oh, Musk!
So, but there's a lot of great space events this year, considering we've had a torrid 2020. There's a lot. And as I was writing these notes, Chris, I've come up with a great idea.
Yeah.
It doesn't happen very often. But I'm going to have the Interplanetary Podcast Voter Awards.
Brilliant.
What do you think?
Brilliant. It needs a theme tune, though. I mean, come on.
Oh yes, well, okay. We'll by next week I'll have a theme tune. The
Brilliant.
Interplanetary Podcast Voter Awards. It'll be something like that.
Yeah, fantastic.
I can't wait. Yeah.
Can we get Jamie back to like present it or something? That'd be brilliant.
Oh yes, Jamie can present the Interplanetary Podcast Voter Awards on the final show of the year for definites.
Yeah.
Whether he likes it or not, he's coming back to do that. So I've got four. Yeah, dragged in. I've got 4 categories, unless anyone else moans and thinks I should add an extra. But best space event.
Yeah.
Best space legend.
I know mine.
Best rocket.
Whoa.
And best bit of science.
Quality.
So there's 4 categories. So I want the listeners to get their nominations in this week. You can obviously do it on info@interplanetary.org.uk or just send it over to Twitter. I'll stick a kind of form on the website as well, so you can add it there as well. But yes, get your nominations over. I'll read out the nominations next week, and then Jamie will read the winners on the last podcast of the year. What do you reckon?
Amazing. If he's available, of course.
He will.
I've just completely thrown him into the mix there, haven't I?
Even if he's not available, he's doing it. It's as simple as that.
Definitely. What we could do is get all the previous episodes and just piece together like words that he said to make it sound like he's actually doing it.
Well, that's what deep fake's all about, Chris. I've got hours and hours of Jamie footage, so that's fine. That's good. It'll be easy. Yeah. That's it. I'm deep faking Jamie.
Deep fake Jamie.
Who's to know that this whole podcast hasn't been deep fake Chris and Matt?
Exactly. I'm out tonight. I'm out on the town.
Yeah. I died 2 weeks ago.
I think I just maxed out my microphone when I laughed then. Sorry.
Said your avatar. It's very clever, isn't it, these days, those things? Yes. Here's the science news of the week, I think. Breakthrough in the sun. Mm-hmm. So the Borexino collaboration has finally seen evidence of a process in the sun that was theorized but never observed. So if you want to know what Borexino collaboration is, it's a particle physics experiment.
Do you know what? Is it the world's most radio pure liquid scintillator calorimeter?
Do you know what? It really is, Chris. And it's in a stainless steel sphere which holds all the signal detectors, these photo multiplier tubes, or PMTs as you call them.
Yes, I do.
And it's shielded by a big water tank, which protects it from all this external radiation. But the water tank also acts as a way of tagging incoming cosmic muons as well, which is pretty cool, isn't it? But only a few of them get to it because this is built inside a massive mountain. So the mountain strips off pretty much everything coming in except neutrinos that are supposed to be coming from the sun's core. So neutrinos are emitted during the fusion process at the center of the core, which powers the sun.
Yeah.
And it's the only direct probe we have of the sun's really deep interior. So these neutrinos coming out of the core are actually a way of peering inside the sun.
And also,
really
it's a little bit it's a little bit of a time machine as well, isn't it? Because they take hundreds of thousands of years to get from the core to the surface. Is that right?
No, I don't think the neutrinos do. I think the photons do.
Oh, that's the one.
Photons.
Damn it.
The photons take absolutely ages, to get out of the sun because they're bouncing around all over the place, which just makes you realise what? For the photon itself, of course, it took no time at all. But for us watching the photon, it took forever.
Yeah.
Or a long time anyway. Here's the special bit about this. So stars are fueled by fusion of hydrogen into helium, right?
Correct.
And that fusion is understood theoretically in very, very great detail. And they know it happens via two processes, the proton-proton, or the PP chain, and the carbon-nitrogen-oxygen CNO cycle, right?
Yeah.
So neutrinos are released by both of those processes, but 99% of the sun's energy, and it's only the sun, or stars like the sun, 99% of the sun's energy fusion comes from the PP chain.
Yeah.
Chris, can I ask you a question?
Yes.
In Liverpool, do they have the expression to pull the chain when you go to the toilet?
Yeah, or flush the bog.
Flush, yeah. Obviously, it means flush the bog.
But you pull the chain. Yeah.
Did you remember to pull the chain?
Yeah, if you pull the chain, lads.
Did you pull the chain? Oh, so you still have it. So
give it a couple of minutes, Mum. Yeah.
PP chain is most unfortunate, isn't it?
Yes, it is.
I went for the PP. The neutrinos from this process have already been observed by the Borexino, so that is not really up for debate at all. So they've seen the neutrinos from the PP chain, but they've never spotted the neutrinos from the 1% CNO cycle until now.
Wow!
So over the last 5 years, they've been improving the sensitivity of the detector, and a lot of that is to make it thermally stable. So presumably, it's the fluid that's in it is just absolute. They know exactly what temperature it is, and it doesn't fluctuate. And that's allowed them to compensate for the noise that's caused by any contamination, which apparently is the decay of bismuth 210. So they're only counting a few neutrinos a day that are associated with the CNO. And bearing in mind, neutrinos are coming through in their billions, that, the few neutrinos that they know are coming from this type of CNO decay isn't very often. So the noise had to be reduced massively so that tiny signal can make it over that noise floor, which is, again, it's just remarkable, the instrumentation these days, and just how amazing the instrumentation is, and
it's mind-boggling.
That's what it's all about. Honestly. It is mind-boggling.
The sort of micro detail is unbelievable. I can't even begin.
The CNO, and this is the cool bit. So they have spotted these neutrinos coming from the CNO. Obviously, the CNO, carbon, nitrogen, oxygen. This kind of way of detecting neutrinos now could be a way of measuring the abundance of those atoms in the solar core, so the solar metallicity of what it's like at the core of the particular star that you're looking at.
Wow.
And I said the sun, the CNO cycle, is only 1%, but in massive stars, it's actually the dominant process. So it's not the PP chain in big stars, it's the CNO.
Yeah.
And so if you think about it, this is the first time that we've experimentally observed the primary mechanism for the conversion of hydrogen to helium in the universe. So that's got to be up for a mention at the Nobel Prize, I would have thought. An
honourable nod, I think.
Yeah, yeah, absolutely. Crikey, we've got one big one this week as well. That this was coming on the Discord, but I tell you what's a real coincidence. I want to make the space word of the week.
Space word
of the week was the cosmic web.
Yes.
And one of the reasons why is because George and I have been been falling out really over trying to create this animation, 3D animation of the cosmic web turning into the human brain synapses. I thought it was a good start to a video that I'm trying to do for the Space Store. A little collaboration I've got going with them, which we're trying to, do a little pilot episode, and this cosmic web turning into the human brain to sort of express how the universe is massive, and we might be the only thing where matter has somehow bizarrely assembled itself to be able to have consciousness and think about the universe.
Yeah.
But there's been a paper released that talks about the remarkable similarities between this cosmic web and the human brain, and this is something that people have talked about over the years, but this is a sort of really good general analysis of the similarities and actually how spooky it is, and that there's some deep, profound things in there.
I feel like I'm going to have to align my chakras before I continue.
Yeah, it's very spiritual, Chris, this part of the show. My spiritual chakras are telling me you need to give me your car, Chris. You need to give up all your worldly goods. Yes, there was an exhibition in San Francisco that had all this kind of stuff in, but then I started to think to myself, well, what exactly is the cosmic web? I mean, it gets bandied around and we've seen the picture. But actually, the cosmic web deserves a quick space word of the week because it's important, I think. Yeah. So what's incredible, when you look up at the night sky and you see all the stars and you think, they're pretty random, right? You look out and it's all randomly spaced, and okay, there's little lumps there and little lumps there, but that kind of is pretty indicative of a random distribution of things, right?
Yeah.
I mean, the crazy thing about that is, of course, all the stars, all those countless stars that you see in the night sky are all actually pretty close to us, and you virtually see no other galaxies, except maybe if you've got incredibly dark skies, very good eyesight, you can just about make out Andromeda through averted vision, i.e. through the corner of your eye as a smudge. And so occasionally you can just about glimpse Andromeda with the naked eye. And maybe a couple of other galaxies that are as close, part of the Virgo cluster of galaxies. And they're the most distant objects you could possibly see. But most of the stars in our own galaxy, we don't see them even. Just the sort of local stars that are around us. So discovering this cosmic web, which is on a completely different scale, is just an achievement in itself of mankind. So what you need is something as powerful as Hubble to look really deep, and Hubble really only sees galaxies. And in the same way that we see stars. So it sees all these galaxies, and everywhere it looks like they're fairly, randomly distributed. Astronomers have looked closer and really found, no, this isn't a random distribution at all. There is actually something else going on. You do actually start to see more structures built into the universe on an absolutely vast scale that isn't random, and that is the cosmic web. And when you sort of zoom out and you see these computer simulations of the cosmic web, or how astronomers have built what the cosmic web actually looks like, it does look like a sort of spider's web, and it's galaxies and galaxy clusters and the filaments of gas that stretch between them, and it creates this web, and there's large voids in between all of this where there's literally nothing. Yeah, and it's like, well, how did that come to be?
I'm scared, Matt.
What, of a big spider in the universe of cosmic
I'm
web?
scared of a giant spider, but I'm also now afraid that I'm inside someone's brain.
Well, yeah, I mean, the crazy thing is, as you'll hear, there are incredible similarities. But we did an episode a long time ago now, it seems like over 100 episodes ago, about baryonic acoustic oscillations, and that is one of the reasons why you've got this non-randomness in the structure at this vast scale. Because, here's the thing: you've got this tiny, dense universe right at the beginning, like incredibly tiny, incredibly smooth as well, but it's not perfectly smooth. After a millionth of a second, and for the first 379,000 years, the universe was just this plasma of electrons, protons, neutrons, and other baryonic matter, and especially dark matter and photons. And it's just way too hot ever to sort of coalesce down into any kind of matter at all. So it's just plasma. And this is for the first 379,000 years, from a millionth of a second. So after a second, the observable universe was about 10 light years in radius.
God, they have to wait ages for that, didn't
and
they?
That's it. So that obviously it's inflated. That first fraction of a second is in this ridiculous piece of inflation. And perhaps more happened in that first second than has happened afterwards. That's the crazy thing. But in that intense glowing soup that was there of photons in this plasma, photons can't really work as light because they're bouncing around. They can't go in a straight line. So they keep bumping into electrons. And so there is no light. But around about 379,000 years after the Big Bang comes recombination. And that's as the plasma reaches this magic temperature where the electrons can be caught by the protons and neutrons and become atoms for the first time. And for the first time in the universe, we have hydrogen. And at that point, the photons are able to go, oh, we've got some room to move now. And actually, that's the first light is born, essentially. And so the observable universe, in terms of what you can observe, starts there. But how can you see beyond this kind of opaque period where light couldn't escape? And the miracle there is that there is these acoustic baryonic waves, and they genuinely are acoustic waves where this plasma was almost ringing like a bell with all this energy, and these acoustic oscillations are forming inside, like almost like ringing around and vibrating. But we can see the fossilized versions of those acoustic vibrations because at some point the universe changed to a point where the speed of sound changed from half the speed of light down to its 100 meters per second type speed at this point of recombination. So the plasma's like gonging around, and then suddenly sound becomes like this slow moving thing. And so it's almost like it's been fossilized, these big bubbles, and this is what actually gives the distance of. If you actually look at the universe, that's still imprinted on the universe itself. So there's this magical bump at 500 million light years between all the galaxies, and that's like this distance comes up far too often, and it's this echo from these acoustic baryonic waves essentially placing the galaxies where they were. It's an amazing proof of dark energy and Einstein's cosmological constant and things like that. But it's absolutely, mind blowing. But those acoustic oscillations have given this cosmic web its kind of shape almost.
Sir, I have a question.
Yes, go on, hit me.
500 million light years of distance. Are we talking about distances between galaxies here, or
galaxy clusters normally? I think so. Okay. It's like it's almost these acoustic bubbles are creating areas of. If you think about acoustics, it's pressure waves, and these pressure waves is where material gets denser and not so dense. So, an acoustic propagation of sound is where the air pressure gets dense, and in other words, there's lots of air molecules there, or not so dense where there's not so many air molecules, and that pressure wave propagates by sort of pushing things into each other and making dense areas and not so dense areas.
So this is that was my preamble. This is my big. This is my question. How does this comply, or how does this apply to the fact that the universe is expanding?
This is a really honestly that gets to the nub of this whole thing, because gravity, that inflationary period in the first second means that gravity is almost playing catch up. So, and I've not really thought of it like this way before, and I still don't think I've completely grasped it. But I love this whole thought that gravity is almost playing catch up. So gravity moves, even though it's completely, an infinite force. It still moves. Its effect still moves at the speed of light. So it can't affect things instantaneously. It takes the same amount of time as light does to get there. So gravity has been pulling bits of the universe together. So after the Big Bang, these small changes in density mean that slowly gravity is pulling in those areas more and more and more. And as gravity sort of permeates through this new universe, it creates the first stars. So there's just about enough gravity to pull all this stuff together, and the first stars start getting made. And then they blow up and then seed more stars. And then gravity is able to pull more of these stars and more of these stars together and create galaxies. And that's only after hundreds of millions of years. Tens of millions of years for the first stars, hundreds of millions of years for the first galaxies, then billions of years for the galaxy clusters and superclusters. And this is because gravity is working its way through through space-time and pulling everything together. And so you've got this, and so gravity has essentially built the cosmic web. And things like acoustic oscillations and quantum fluctuations in the early universe have decided what that cosmic web is going to look like. But there's a kind of limit to the structure and permanency of this thing. Just like you said, the universe is expanding. And gravity has been propagating through and pulling all the large structures together. And it's been playing this catch-up game, but it's been playing it with dark energy, right? And it's starting to lose because dark energy is a runaway kind of expansion, and it's getting faster and faster and faster. So the huge structures in the local group of galaxies, and there's this one called Laniakea, which is a Hawaiian term for immense heaven, which is the galaxy supercluster that contains the Milky Way and 100,000 other nearby galaxies. So it's this enormous structure. But unlike the kind of more local structure, but say between the Milky Way and Andromeda, for example, where the gravity has truly got its grip on us. So the Milky Way and Andromeda will come crashing down towards each other as gravity pulls us all in. But this Laniakea structure is too big. It's actually too big. So even though it looks like a structure, it's actually a phantom and will eventually fall apart as the dark energy essentially rips it apart. But eventually, of course, dark energy will encroach on everything and pull us all apart until the heat death of the universe. But
here's Tom with the weather.
So it might be that the universe has peaked in structure right now. So this might be it. This might be the most structured the universe has ever
isn't
been.
That like one of the sort of the sad things is that what we're observing now, we wouldn't be able to observe even if we did exist in 100,000 years. We probably would struggle to observe what we're observing now.
Yeah, it's a bigger scale than that. I mean, maybe if humanity had appeared on the Earth in billions of years, maybe some of the things that we see now will have drifted beyond the horizon of what we're able to see. And you wouldn't be able to work out some of the things of the universe because they've already gone over that horizon. But of course, that may have already have happened. There may be things that are clues into how the universe was created that have gone beyond our horizon. If I know, which is pretty mind-blowing. But back to this paper, this recent paper that is looking at the human brain. Is the brain and the universe, this cosmic web, have unbelievable, remarkably similar structures, right? But even though one is caused by biology and the other is caused by gravity, they're totally different things at play, but they've created patterns that are really similar. One's on a vast scale and one's on a tiny scale. One's almost as tiny as it could be and one's almost as vast as it could be. So the brain is a billion times smaller than the universe, yet it's got 69 billion neurons in it. And the cosmic web contains, in the visible universe that is, contains about 100 billion galaxies. So about the same order of magnitude. So there's the same amount of galaxies as there are neurons for one. So that's a pretty kind of correlation.
Yeah.
The neurons in the brain and the galaxies in the universe are all connected by these filaments. The brain is about 77% water and the universe is around 72% dark energy. So they think that there may be a connection between those two things, these things that apparently play no part, but are clearly important in the creation of the structure itself. And there's crazy things like that. The distribution of the fluctuation within the cerebellum neural network follows the same progression as the distribution of matter in the cosmic web, but obviously on a completely different scale.
Yeah.
There's roughly 4 connections per node. So each galaxy is connected by filaments to other galaxies usually by 4 different filaments, and the same with neurons to each other. And so, interestingly, yes, a whole human experience could theoretically be encoded in the structure of the universe. So the structure of the universe is complex enough that it could hold Chris Carney, all his memories and experiences.
So, Matt, one of the things that we can't really explain is consciousness, and another thing that we can't explain is dark energy. What if dark energy is consciousness?
What if indeed? Well, I mean, you're getting dangerously close to things like panpsychia there. But hey, I mean, like all the time, there's this big gap in knowledge. And let's face it, dark energy, dark matter, consciousness. We're talking some of the big questions. I mean, when I was a kid and Stephen Hawking would talk about, the theory of everything and things like that. And I thought, we were on the cusp. And then you think, we're absolutely miles away from a theory of everything, really. Unless someone, in the next 10 years, we might have cracked it. Someone goes, I know what dark energy is. And look, all of this falls out like really neatly. Consciousness, dark matter. It all comes out.
We worked it out.
It all comes out in the equation. It turns out it is turtles stacked up on top of each other. It's amazing.
Wow, that has been an absolutely mind-blowing adventure, man. Brilliant.
Oh,
I'm glad these edibles are just about to start kicking in. So I mean,
well, yeah, I'm gonna have to. I love it. I do love that connection between the brain and the universe is really fascinating. I mean, I think it's much more to do with sort of complexity and how complexity can actually come into creation. How is it created, and that there are, and I love things like the Mandelbrot set and all those kind of things that generate complexity from simplicity. And you think, that it's the same with the universe, the same with the human brain, that these structures, that there's these sort of simple causation for them, but it creates these absolutely amazing objects, the brain and the universe. I just don't know what's more exciting, the human brain, human biology, or astrophysics. It's hard to tell which one is the most mind-blowing. They're both incredible.
And of course, the irony of it is that we use the human brain to study the universe, Matthew.
And we use the universe to study the human brain.
Yes, we do. We do.
Oh, crikey. Or as Carl Sagan said, the universe has found a way to know itself. Or something like that. I can't remember exactly what it is.
He said something like that. He said a lot of things.
He did say a lot of things. You should shut up,
all of them
Sagan.
Great.
Oh, all of them great. Sorry. I mean, that's what I meant.
Come on, dry up, Sagan.
No, dry up. Yeah, stop being so blooming, so good with words. Chris, that's it. We've come to the end. So don't forget there's a task for the Spodcats this week, and that's to come up with the nominations for Best Space Event, Best Space Legend, Best Rocket, and Best Bit of Science of 2020 for the Interplanetary Podcast Voter Awards.
Amazing. And I'm trying
That's just
not
the
to,
nominations, just nominations this week.
I try not to influence people who I think my space legend is. I'm not going to say.
Well, no,
anything.
that's okay. Who's your space legend of the year? Oh, good one. Yeah, I think that's a very good choice. Oh, so and you know, or yeah, it's going to be hard to beat that one if that actually comes off. So
are we forcing the voters' hands here? Are we forcing the voters?
No, because someone might have a completely different. It might be that might be people's favourite.
Dude, also I know the Spodcats are rather they have their opinions and they are strong.
The Spodcats have got very, very strong opinions on things. It's been a long podcast. I thought it was going to be a short one. It ends up being a long one.
It's been a beauty, though. Absolutely loved it.
Until next week.
Yes.
And the nominations read out next week. Bye,
yes.
Spodcats.
Bye, Spodcats. Bye, Spodcats. Bye.